Today we'll go through theorem of parallel axis. What is that? Theorem of parallel axis. See, it states that moment of inertia along any axis, that let us suppose that is CD, is equivalent to the moment of inertia. Let us suppose this is Ri, this is Mi. See, moment of inertia along any axis CD is equal to the moment of inertia along the AB, that is which passes through the center of mass, and m total mass of the body into square of distance between the new and old axis. We have, let us suppose we take a certain mass Mi. The moment of inertia along the CD will be equivalent to what? Sigma I is equal to 1 say I is equal to n. It goes from Mi, this is Ri plus h whole square. So what we'll do is that this is I is equal to 1 up to I is equal to n. What we'll do is that this is, I will expand it out. This is coming out to be r square h square plus 2ri into h. And now what we'll do is that we'll expand it out. This is I is equal to 1 to I is equal to n. This is what? Mi into ri square. This is what? Sigma I is equal to 1 to I is equal to n mi into h square, and sigma I is equal to 1 to I is equal to n. This is 2 mi into ri into h. See, you'll see that the value of I is equal to, this is what? I is equal to AB is equivalent to sigma I is equal to 1 to I is equal to n. This is mi into ri square. How come? See, when we place the value 1 r1 square m2 r2 square, it is coming out to be the same thing. Similarly, this is, suppose we expand this out, it is coming out to be mh square. This is I is equal to 1 to I is equal to n. This is mi into h square. When we place these values up to mn, it is coming out to be mh square. And we know that these certain masses are over here, lies on the axis CD, and that will coming out to be 0. How come? This is I is equal to 1, I is equal to n. This is 2 mi ri into h is going to be 0. Thus, we are able to prove that moment of inertia along the new axis CD is equal to moment of inertia that passes through the center of mass plus total mass of the body into square of distance between new and old axis. That's it for today.